Another type of sequence in series that we run across often is called a geometric sequence. A sequence is geometric when the ratios of consecutive terms are the same. We call it a common ratio. And so if you take the second term divided by the first term, or the third term divided by the second, or the fourth divided by third, those are all going to be the same thing, and it is this common ratio. Now, what this means is, remember, in arithmetic sequences, we were adding a number over and over again. So maybe we did 2, 4, 6, 8, 10, okay, where we were adding or subtracting a number over and over. Geometric sequences, we are multiplying by a number over and over. Okay, so maybe 2, 4, 8, 16, 32. So we have this common ratio that we're multiplying by. That common ratio can be a fraction as well. So maybe something like, there's another example of a geometric, maybe something like 25, 5, 1, 1/5, and so on. You could describe this as, to get to each term, you're dividing by 5, or what we more commonly say is that you are multiplying by a fifth over and over. Okay, so that's another geometric one. The other thing about this is, we didn't really talk about this, but if you take an arithmetic sequence and you graph it, so the first term is 2, the second term is 4, the third term is 6, the fourth term is 8, you're going to find the arithmetic sequences are linear, okay? And whatever the common difference was is the slope. When you graph geometric ones, the first term is 2, the second term is 4, the third term is 8, the next term is 16, you'll find that these are exponential growth or decay. So we'll see that in our problems. But arithmetic are linear and geometric are exponential. Now, just like in arithmetic sequences, we have a formula for finding the nth term of a geometric sequence. That's right here. It's an is a1, the first term, times r, your common ratio, raised to the n minus 1. And you can see from the formula that this is going to be exponential. It'll be exponential growth if r is greater than 1. It'll be exponential decay if r is between 0 and 1. If r is negative, it does this weird oscillating thing, kind of bouncing back and forth between numbers. All right, so we want to write the first 5 terms of a geometric sequence whose first term is 2 and common ratio is 4, and then we're going to graph those. All right, so the first term is 2. The common ratio is 4, so we wanted the first 5 terms. 2, 3, 4, 5. All right, so to get to the next number, we're going to multiply by 4. And then we're going to multiply by 4. We're going to multiply by 4, and the numbers all of a sudden got really big. We're going to multiply by 4. Okay, and then to graph these, okay, remember this is the first, second, third, so that's kind of like your x coordinates. So 1, 2, 3, 4, 5. And then I'm going to have to scale this axis, not like that. There's the undo. Oh, well, that was not quite what I wanted, but okay. When you graph these, you're going to have to scale very differently because these take off pretty quickly. So I'm going to scale these by hundreds. Okay, so our first term is 2, and our next term is 8, and then 32, and then 128, and then 512. So you can see that is definitely exponential. All right, we want to find the 12th term of a geometric sequence whose first term is 14 and common ratio is 1.2. So we're going to use the formula that we discussed. An is a1 r to the n minus 1, that formula. So whatever term we want to find, we'll have to take 14 times 1.2 to the n minus 1. And now we want to find the 12th term. Now, when you go to put this into your calculator, you have to put that exponent in parentheses or do it in your head. Do 12 minus 1 in your head and just type 11 into your calculator. But if you don't put that in parentheses, your calculator is going to raise 1.2 to the 12th power and then subtract 1, which is going to give you a wrong answer. Okay. So when you do this, you should get 104.02. Okay, I encourage you to do that in your calculator. Make sure you get the same thing as me. All right, let's try one more of these before we end the video. As we talked about in the last lesson, the calculators can do this with the table feature on the graphing calculators. It's kind of a lot of work to set up. It's probably just as easy to plug in. So sometime when we see each other in person, you can ask me how to do that on your calculator. All right. We want to find the 12th term of this geometric sequence. Okay, so we're going to need that formula. Our first term is 4. We know the common ratio, which looks like we're multiplying by 5. And now we want to find the 12th term. So we're going to do 4 times 5. And again, put that in parentheses, otherwise your calculator is going to tell you wrong things. Or just do 12 minus 1 in your head. And this is a really large number. Excuse me. 195,312,500. Okay, the second term of a geometric sequence is 6, and the fifth term is 81/4. Find the 8th term. Okay, so we don't know the first term. We know that the second term is 6, 3, 4, and the fifth term is 81/4. Okay, so what we've done is, well, let's think about what we want to do. Find the 8th term. So really, we want to work with our formula. This guy. Okay, that's our goal. So we need the first term and we need the common ratio. So let's tackle the common ratio first. What we've done is we've taken 6 and we've multiplied by our common ratio, we've multiplied by the common ratio, and we've multiplied by the common ratio. So we took 6 and we multiplied by r times r times r, which is r cubed. And that got us 81/4. Okay, so now I'm going to divide both sides by 6 or multiply by 1/6. And that gives me, I think 27/8 when that's all said and done. And then I'm going to take the cube root of both sides, and that's going to give me 3/2. So that is my common ratio. So, oh, and I also want to back up because I want to find that first term too. So to find that first term, instead of multiplying, remember this direction, we're multiplying by 3/2. If I take 6 divided by 3/2, that's going to take me back the other way. So it looks like the first term is 4. So now that we know that information, our first term is 4, our common ratio is 3/2. So we have a fantastic formula that we can use to find the 8th term. Our 8th term is going to be 4 times 3/2 to the 8 minus 1, which you're putting in parentheses. And when you do that, you end up with 2,187/32. We do usually want to give fraction answers for these. They are more exact than decimal ones. So do put your answer in fraction form as often as possible.